Hi, we are the IMPULS Mars rover team from Kielce University of Technology. We design and build rovers for international robotics competitions. This year we present our latest generation IMPULS 3 rover, developed specifically for the European Rover Challenge 2026 with a strong focus on reliability, modularity and real mission performance. Our team is structured into 5 primary sections: design and mechanics, programming, electronics and communication, science and documentation, along with a dedicated public relations department. All subsystems are designed, manufactured, and integrated in-house. Through continuous collaboration and iterative development, we ensure that every component works reliably as part of a complete system. Regular field tests and integration sessions allow us to validate our solutions under realistic operating conditions.
Hi, I am Kacper Świercz, a member of the Design, Mechanics and Aerospace section, which is led by Jakub Górski. My colleagues are Adam Michalczyk, Oliwier Łaski and Filip Urbaniak. We are responsible for our rovers and drones, construction, design and maintenance.
My name is Norbert Kot and I am the leader of Programming, Electronics and Communication section. The support is Filip Konwa, Kamil Góras and Jan Biernacki. We are ensuring that rovers' embedded systems are reliable and communication systems are working as intended.
Hi, my name is Wojciech Łakomiec. I'm the leader of the Autonomy section. My teammates are Michał Kluzek and Jakub Kamiński. We are responsible for ensuring that our platform can navigate autonomously, smoothly and safely across demanding uneven terrain.
Hi, my name is Piotr Hochu. I am the leader of our group and also responsible for machining mechanical and construction parts.
Piotr Witkowski is the head of the science and documentation. His responsibilities include developing research methods related to detection of living organisms and managing documentation.
I'm Angelika Ben and I'm responsible for public relations. In my team, I have Mateusz Misiak and Krzysztof Kaluga. We manage social media and establish partnership with companies.
Our team's history is strictly connected to the European Rover Challenge. This year, we once again participate in it to push the limits of our engineering capabilities. We want to gain even more practical experience in designing systems for planetary exploration.
IMPULS 3 is a new, approximately 50 kg rover designed to autonomously complete the European Rover Challenge 2026 missions. Compared to previous designs, it has undergone significant modernization, maintaining a weight limit below the 75 kilograms. This makes it more mobile, energy efficient, and has greater structural headroom. Key new features include a lightweight, milled PA6G polymer chassis, modular 3D printed TPU tires, and powerful BLDC motors, with gears and aluminum shafts. The electronics are based on proprietary STM32H7 board and O-drive controllers, enabling the rover to operate autonomously. The autonomy system utilizes Luxoni's OGD stereoscopic cameras with active IR and an NVIDIA Jetson computer. A new dual-mast carbon fiber mast supports communication, status indication, and an emergency stop system. The rover also features a dedicated Astrobio module with an automatic drill for deep sampling and sealed, insulated containers that reduce the risks of sample contamination. The suspension has also been improved, using stronger damping springs, and the robotic arm has 6 degrees of freedom. The arm features reinforced components and new inverse kinematic software, allowing it to perform precise tasks such as operating buttons and keyboards, or grasping Astrobio containers. The proven operator control module in the base station and long-range communication based on SATEL modems and Ubiquiti equipment, which have proven effective in challenging radio conditions. have been retained from the previous solutions. In short, Impulse 3 is a lightweight, durable and autonomous rover, combining a new design, a reliable propulsion system and advanced autonomy system, and a science module designed to meet ERC 2026 requirements.
The rover is operated remotely using dedicated control station that provides real-time video, transmission and telemetry data. Operators can precisely control all subsystems, including mobility and manipulation, even without direct line of sight. To ensure operational safety, the system is equipped with an emergency stop mechanism and automatic fail-safe protocols, which instantly stop the rover in case of communication loss or critical errors. Visual indicators provide clear feedback about the system status during operation.
Our drone is a small test platform in a quadcopter configuration with an X-frame. The design was optimized for versatility, stable flight and maximum operating time. It's based on a 9-inch Mark IV V2 carbon fiber frame, reinforced with custom 3D printed polycarbonate components, while vibration dampening elements are made out of flexible TPU. Controls provided by an STM32F745 flight controller with autopilot. The drone utilizes a suite of sensors including IMU, barometer, GNSS, magnetometer, optical flow, and LiDAR, enabling for stabilization, navigation, and autonomous missions. It is powered by 4 BLDC 2812 900 kV motors with 9-inch propellers and independent ESC units operating in the D-Shot 600 protocol. The system has ample power and payload capacity, allowing for future expansion. Power is provided by a proprietary 6S lithium-ion battery with a capacity of approximately 5000 mAh, made using copper connections to reduce energy loss. Additionally, the drone can be equipped with an onboard computer, either a Raspberry Pi 5 or an NVIDIA Jetson, connected to the camera and flight control via Mavlink. This creates a lightweight, rigid and development-ready platform for testing autonomy and future mission modules.
The rover is equipped with a 6-degree of freedom manipulator designed for precise and versatile manipulation tasks. It enables operations such as grasping objects, handling equipment, and interaction with mission elements. Tasks require high accuracy and control. The end effector has been optimized for reliability and adaptability in various task scenarios.
Our science model enables subsurface sample collection and onboard analysis. The rover is capable of acquiring soil samples from depth and performing basic environmental assessments directly in the field. These capabilities allow us to simulate really scientific missions and evaluate terrain conditions in real time.
Through extensive testing and continuous system improvements, our rover is ready to face the challenges of the European Rover Challenge 2026.